Welcome students to another video. In this video, we will be reviewing the lesson 9-4, area of the rhombi and kites. Let's complete our do now problem. What is the area of the trapezoids in the following figure? From yesterday's lesson, let's recall the formula to calculate the area of the trapezoid. Area equals base 1 plus base 2 times the height divided by 2. Our base 1 will be equals to 3. That is our top base for this trapezoid. And our base 2 will be equals to 4. That is our bottom base. However, we do not know the length of the height. Since we do not know the length of the height, we need to be able to recall and identify the relationship of these special right triangles. Since this is a 30, 60, 90 degree triangle, let's recall the relationship among its sides. We know that the side opposite to the 30 degree will be equals to L. The side opposite to the 60 degrees is equals to L, whatever the short leg is, times the square root of 3. And the side opposite to the 90 degrees will be equals to 2 times L. So in this trapezoid, we know that since the top base is 3, then this bottom side of the rectangle will be equals to 3. And so because the bottom base was 4 and the bottom side of the rectangle is 3, we know that the length of the side, the length of the shorter leg in this right triangle is equals to 1. So because the short leg is 1, then the side opposite to the 60 degree will be the same thing as 1 times the square root of 3. And our hypotenuse will be 2 times 1, which would give us 2. The goal was to find the length of the height, and we have found the height. Now that we know that, we can come back to our formula and continue calculating the area of the trapezoid. Base 1 is 3, base 2 is 4, and the height is square root of 3 divided by 2. Let's follow the order of operations. So start with whatever is in parentheses first. 3 plus 4 is 7 times the square root of 3 divided by 2. We do not need to simplify our answers any further. Since we have found our answer, our correct answer is J. All right. Let's begin with the lesson for today. The objective for today is students will be able to find the area of rhombi and kites. Before I start by introducing the formula to you, I need you to be able to recall some of the properties for the rhombus. In the rhombus, the diagonals are perpendicular. So here, for this rhombus, our diagonal 1 and diagonal 2 will be perpendicular. So super important that you understand that. And also, there's another property that you need to be able to recall about the rhombus, and that is that diagonals bisect each other. So because the diagonals bisect each other, then our diagonals will be cut in half, okay? So let's pretend that diagonal 1 is equal to 10 units. Oops, erase that. It's equals to 10 units. Diagonal 1 equals 10 units. So then we know that both of these parts of that diagonal will be equals to 5. Also, let's pretend that diagonal 2 is equals to 6. then both of the parts of these diagonals will be equal to 3. All right, for the kite, we still need to recall the property that diagonals are perpendicular. Okay, so we're still going to be placing the 90-degree angle where the two diagonals meet. But notice that in the kite, one of the diagonals serves as the axis of symmetry. Okay, so in this particular kite, the diagonal 2 is the axis of symmetry. So that axis of symmetry will be bisecting the other diagonal. So the only diagonal that will be cut in half is that one that the axis of symmetry is bisecting it. So let's pretend that diagonal 1 is equals to 5. Then each part will be equals to 2.5. And now that we have recalled these properties about rhombus and kite, then I can go ahead and introduce the formula to you guys. So the formula that we were going to be using to calculate the area for any rhombi and kites will be area equals diagonal 1 times diagonal 2 divided by 2. So let's look at the first example. Find the area of the kite below. First thing that we have to do is recall the formula. Diagonal 1 times diagonal 2 divided by 2. ln will be our diagonal 1. And again, it doesn't really matter who you label as your diagonal 1 or diagonal 2, because at the end, you're just multiplying these two. So again, it doesn't matter how you label them. But I'm going to go ahead and label the diagonal ln as my diagonal 1. The length of my diagonal 1 is 3 plus 3, which would give me 6 meters. Km is my diagonal 2. And the length of my diagonal 2 will be 7. Now that I have found the length of both of my diagonals, I'm going to go ahead and substitute that into my formula. Diagonal 1 is 6 meters. Diagonal 2 is 7 meters. All of that divided by 2. So 6 times 7 is 42 meters squared. Oops. 42 meters squared divided by 2. And our final area will be 21 meters squared. All right, let's go ahead and move on the second problem. Find the area of the rhombus if one diagonal is 18 millimeters and the other is 24 millimeters. So let's go ahead and do our diagram here for this rhombus. And our first diagonal will be 18 millimeters, and the second diagonal will be 24 millimeters. So once again, let's recall the formula. Formula equals diagonal 1 times diagonal 2 divided by 2. 18 millimeters times 24 millimeters divided by 2, and we get 432 square millimeters divided by 2, and our final area will be 216 square millimeters. So simple. All right, now let's go ahead and look at the last problem. It says find the area of the rhombus shown, and it's also saying that the units are measured in inches. So once again, let's recall the formula to calculate the area of the rhombus. Area equals diagonal 1 times diagonal 2 divided by 2. And in this rhombus, we know that the length of the first diagonal is 10 since it's a rhombus and we know that diagonals bisect each other. So because that's 5, this must be 5 as well. So that's why the length of the diagonal one is 10. Now, we need to be able to calculate the length of our second diagonal, but we don't know it. So we need to be able to calculate that. Again, let's recall that the diagonals in the rhombus are perpendicular to each other. So you can already start thinking about how can we solve for that length of the diagonal. So first, we need to be able to recall and identify the relationship of the Pythagorean theorem because we can already identify that right triangle. And we can use the Pythagorean theorem to help us find the length of the diagonal. I'm going to go ahead and redraw that right triangle so we can see it better. We know that the short leg is 5 and the hypotenuse is 13, right? So anytime we're looking for the leg of the right triangle, we get the hypotenuse squared minus the leg squared. So that will give us x equals 12. And again, this is 12, but we're still looking for the length of the diagonal 2. So we need to add that twice or multiply it times 2. And we get that the length of the diagonal 2 is 24 inches. Okay. So again, guys, I'm going to stop right here real quick. Whenever I am not giving a dimension, even in the previous lessons, we know that we either have to use Pythagorean theorem or special right triangles depending on the information that we have on that specific shape. For this particular case, I didn't know the diagonal 2, so I needed to use Pythagorean theorem in order for me to find that missing dimension, that length of the diagonal 2. Once we're able to figure that out and calculate that information that we needed, now we go back to our formula to finally finishing calculating the area for this rhombus. So diagonal 1 is 10 units, 10 inches. Diagonal 2 is 24 inches. And all of that I divided by 2. So 10 times 24 would give me 240 square inches divided by 2. And my final area will be 120 square inches. Okay, thank you guys for watching this video and have a great day.